my first recording from the Science Academy. Now that South Texas ISD said that teachers need to come back to the classroom, I'll try to make my recordings here. This will be the 5th time I've started this recording though, because either there's announcements or there's no mic. Definitely not at home in Mrs. Leonard's house in McAllen, Texas. But this time if there's announcements, I'm just going to keep talking because they have told us that we are not video editors. We do not need video editing software. We are teachers. So this isn't going to be pretty, but it's going to work. Here we go. Lesson 3.2 is angles and parallel lines. And I'm going to start off with this warm-up, which you are not required to write in your on your paper. But there's three warm-ups. That's not what I meant to say. What I meant to say was 3 lines, okay? When you have 2 lines, like line M and N, and they're crossed by a 3rd line, and it crosses both of them, it's called a transversal, remember? I taught you that in chapter 3, section 1. So line L is a transversal, and when it crosses the other 2 lines, it creates these 8 angles, and there's a special relationship between them. When lines M and N are just random lines laying in the plane, there's not a special relationship in the angle measure, but they do have a name. So angle 1 and 5 are called corresponding angles. Angle 3 and 8, those are both on the interior. Remember the interior and the exterior angles? 2, 3, 5, 8 are interior angles. 1, 4, 6, 7 are exterior angles. So 3 and 8 both being interior angles, and they're both on the same side of the transversal. They could be called same side interior angles or consecutive interior angles. Okay, and then angle 4 and angle 6 are both exterior angles, and one's on the right and one's on the left of the transversal, like as if they're alternating sides. So they're called alternate exterior angles. And going back to number 1 and how it was corresponding angles, recall that, if you will, that's the only special angle pair that has one interior angle, that's angle 5, and one exterior angle, angle 1, and they're both on the same side of the transversal. Okay, so what happens if the 2 lines that are just laying around in the plane are actually parallel, and then a transversal comes along and cuts them and creates 8 angles? What happens is all of the angles in that, out of those 8 angles, there's only 2 measures. Sometimes they're equal to each other, and sometimes they're supplementary. Like we learned in chapter 1, angle 1 and 7 will be equal because they're vertical angles. Angle 1 and 2 will add up to 180 because they form a linear pair. They're beside each other. Well, now, if I know that, well then, a library headphone and cable and mic. Okay, it's kind of long, got stuck. So we'll start with corresponding angles. So the corresponding angles would be angle 1 and angle 3. Remember, that's the angle pair where one is an interior angle and one's an exterior angle, and they're both on the same side of the transversal, in this case above the transversal. Angle 8 and angle 6 are also corresponding angles. Dude, they're all equal, okay? That's what congruent means, same shape and size. So here's an example where they're giving you angle measures, and they're saying angle 18, the measure of angle 18 is 42 degrees. There should be a degree symbol. So then they're asking you, what about the measure of angle 22? So before I do anything, I see what's the relationship between angle 18 and angle 22. 18 is an exterior angle on sort of the left of the transversal. 22, an interior angle sort of to the left of the transversal. Those are corresponding angles. Surprise, surprise. They are going to be congruent. Yes. And if the question says justify your answer, that's how you justify your answer. You say the measure of angle 18 is 42. The measure of angle 22 equals 42 because you could say because they're corresponding angles, or you could say because of the corresponding angles postulate. In part B, they're starting again with angle 18 equals 42 degrees. And now they say, what about angle 25? So knowing nothing else, I could say, well, because angle 18 and 25 aren't corresponding angles. 18 and 22 are corresponding angles, and 22 and 25 are vertical angles. So it will equal 42 degrees. And if you need to explain it, you could say, because of the corresponding angles postulate, I know that angle 18 and angle 22 are congruent angles. And then because of vertical angles, I know that angle 22 is congruent to angle 25. Or you could just use the alternate exterior angles theorem, which states that if you have two parallel lines cut by a transversal, then each pair of alternate exterior angles is congruent. So in this case, 5 and 7 are exterior angles and they're alternating. So they're called alternate exterior. And that's exactly what we had in this situation. Angle 18 and angle 25, 18 was on the left, 25 was on the right. They're both exterior angles. So if you need to justify your answer, you could also use the alternate exterior angles theorem. There's also an alternate interior angles theorem, angle 1 and 3, angle 2 and 4. And it says if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Cool. And the last one, because remember there were 4 pairs of special angles formed by a transversal crossing two lines. There were corresponding angles, alternate interior angles, alternate exterior angles, and those 3 all end up being congruent angles. There was also the one that I made a big deal because I like calling it same side interior, and this book calls it consecutive interior. That's the only one that had the relationship is supplementary. Okay, so like for example, angle 1 and 2 being on the same side of the transversal above it in this picture, and interior angles, they would add up to 180 because this theorem states if 2 parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. And don't get hung up on the fact that these are all theorems, and the first one I told you was a postulate. Theorems and postulates, when you're in high school geometry, especially nowadays, you don't really need to know the difference between them. It has to do with the level of proof that they underwent to become a theorem or a postulate. If you tell me alternate interior angles are congruent, I'll take it. Okay, so don't get hung up on that. When it says name a theorem or postulate, don't be like, well, I don't really understand what that is, because you probably wouldn't, and that's okay. You could think of it almost even like a definition if you want to, for our purposes. So here we go. This, I was going to skip this problem because it's kind of terrible because they don't have the little triangles to show you that the lines are parallel, and you should never assume that. So skipping, but do note that, let's say they did say they were parallel. And then we're talking about angle. What you do is to read these, I will use it because it is a nice picture. So let's say that the first sentence got deleted and it said, 3 parallel lines are crossed by 2 parallel lines, okay? Then I can just assume all the lines are parallel in this picture. And maybe they think because they said they're floor tiles that they're all uniform. But if they're like man-made tiles, they're not going to all be the same. But let's say they were made at a factory and it's very precise. Okay, fine. I'll give it to you. Maybe they're all parallel. So in this one, the way you know that angle 3 is going to equal 125 if angle 2 is equal to 125 is because angle 2 and angle 3 are alternate interior angles. Notice what they did here. The difference between this statement and this statement is very subtle. This has the congruence symbol, because that's like saying the shape of this angle is the same as the shape of this angle. By definition, that's what congruent means, same shape and size. So because they're the same shape and size, their measures will be equal. You need to have this somewhere saying that the measure of angle 2 equals a measure of angle 3. So that when you put a little m in front of it, that means that you're talking about a number, like 125 degrees. Okay, and then this example over here, if you're talking about angle 2, so, and this is how you do it. You see what they give you and you see what they want, and then you find out what's the relationship before you just start putting numbers on the page. So stopping to think, angle 2 and angle 4. Angle 2 is an interior angle on the left side. Angle 4 is an exterior angle on the right side. And remember the homework from last time where we just had, my pointer keeps disappearing. Let me make it a laser pointer. Where you had to identify the transversal first. So notice that 2 and 4 are both lying along this transversal. So I'm ignoring these other 2 lines. And angle 2 is an interior angle on the left. Angle 4 is an exterior angle on the right. There's no special angle pair that identifies those 2 angles. So what you could do is you could, if since you have to justify it, you would say, well, I know that angle 2 and angle 3 are congruent because they're alternate interior angles. And I know that angle 3 and angle 4 are supplementary because they form a linear pair. So therefore, angle 2 and angle 4 will be supplementary. So what's 180 minus 125? That will be how you get it, because angle 3 plus angle 4 need to add up to 180. The measure of angle 3 plus the measure of angle 4 needs to equal 180. Since angle 2 and 3 are 125, that means this is 125 degrees. So if I went around a circle, and this is going to take me halfway around, from here to here is 125 degrees. How many more degrees do I need to make 180? So that's why you take 180 minus 125 and you get 55. If you don't believe me, you could ask Siri. Alrighty, now there could be some that have algebra. This one's, thank goodness, is clearly labeled. It's got the little pink triangles here and one on each, so that means those two are parallel. The little pink triangles here indicate parallelness, and they've got two here to indicate that these two lines are parallel, but they're not parallel with those two lines. Okay, so they're giving you angle 5 and angle 7. What is the relationship between angle 5 and angle 7? So at this point, I'm ignoring line N. Line M is the transversal, and angle 5 and angle 7 are both on the left of the transversal, and one's interior and one's exterior. Corresponding angles, boom. The corresponding angles postulate states that the angles are congruent, and the definition of congruence said that their measures will be equal. So then you just algebra, and I'll click through that because you can always slow down, rewind if you're not sure how to algebra from there to there. And it just said to find X and to explain your reasoning. Okay, so they explain the reasoning step by step. You could do that that way if you want to, or you could do it all at the end. Okay, on this one, they're giving you angle 4 and angle 8. What is the relationship between 4 and 8? Well, now I'm looking along the transversal N. I'm going to ignore line M. Angle 4 and 8 are both on the right side, and they're both exterior angles. And there's no such thing as same side exterior angle theorem. There's nothing like that. So don't tell me that. It's up to you how you want to use it. But since they're giving me angle 4 and angle 6, it seems logical to start there. Angle 4 and angle 6 are going to be supplementary, and angle 6 and angle 8 are going to be equal. 4 and 6 are supplementary because they form a linear pair. 8 and 6 are congruent or equal in measure because they are corresponding angles. So here they go. They're starting with the corresponding angles. Angle, that was for you, Julian. So angle 8 is congruent to angle 6 because of the corresponding angles postulate. And then they can say that the two measures are equal. And so therefore, now they know not only does measure of angle 8 equals 4y, now they know that the measure of angle 6 equals 4y. They call that substituting because they substituted the measure of angle 8 here and they just left that the same. So now we know that angle 6 is 4y. We know that angle 4 is this. So 4y plus that is going to end up equaling 180. And I know some of you hate solving that kind of equation, but it's not going away. Just saying. So remember from the last slide that 4 and 6 end up adding up to 180, and then 6 is 4y, and 4 was 4 parentheses y minus 25. And then you algebra, you end up distributing this, so you're going to get 4y minus 100 on the next step, distributive property. And then you add these two together, you get 8y minus 100. That's just called simplifying. And then they added the 100 to the other side. You could also call that adding like terms. And then you divide by 8 and you get y equals 35. And you're done. More of the same. They're giving you angle 1, angle 2, and angle 3. So the relationship between angle 1 and 2 is that they're going to be equal. The relationship between angle 2, okay. And when you're looking at angle 1, I just say it like that. Oh, they're going to be equal. But let me tell you in case you're confused. How do I know? I look at angle 1 and 2, and I notice that they're both formed by this line, C, crossing lines A and B, because angle 1 is formed by these two rays, and angle 2 is formed by these two rays, and this ray is along line C, and this ray is along line C. Line C is the transversal, if you're still having trouble with that. So then I'm looking at A and B, and I'm noticing that those two are exterior angles, and they're on either side. They're alternating from top to bottom, so they're called alternate exterior angles. And now to just say, oh yeah, and so angle 2 and 3 are equal. Well, that's because I've been doing this a while, okay? So 2 and 3, they both lie along line B, so that's a transversal at this moment. This is my focus. And then C and D are the other two special parallel lines. 2 is above C and to the right of the transversal. 3 is above D and to the right of the transversal. One's an interior angle, one's an exterior angle. Corresponding angles postulate, so they're also going to be equal. So if you wanted to work those out, you could see if you get the answers that they're saying here. Here's another example, same situation, different things given. Oh, because notice, if you will, that angle 3 has a Y in it. So to find, this is why they asked them in this order. First they said find X. So you would find X by putting angle 1 and 2 equal to each other and solving for X, and you get 12. So what is the measure of angle 2? It's 12 times 5, which is 60. 60 minus 3 is 57. 57 times 2. Hey, Google, what is 57 times 2?
The answer is 114.
114, obviously. So this is a 114 degree angle. So angle 3 is also going to be a 114 degree angle. And angle 3 is given to you with an expression that has a y in it. So you have to take that number and set it equal to 5y plus 14. 114 equals 5y plus 14. Oh, that's nice. I can even do it in my head. So if I subtracted 14 from 114, I get 100 and divide by 5. That's where that comes from. Alrighty. And there's this one other theorem that it's kind of like it makes sense that it would be true, but sometimes it might come in handy. And it says that if you have a plane that has a line, like let's say line A is perpendicular to line T. This little symbol right here says right angle 90 degrees. So if line A is perpendicular to line T, and you also know that line A is parallel to this other line, then now you know that line T is perpendicular to line B. A lot of geometries like that. You're like, well, of course it is, because of the way that they are. But it might come in handy to know that, so I thought I would let you know. And no announcements occurred? What? Cool. I hope that this helped.